Today is 12th October 2020, and we will continue from the previous topic now. So from previous line here, we can write Pn at t plus h, that is equal to the probability that there was n minus 1 number of person in time t period is given by Pn minus 1 in suffix at time t. Now probability for one arrival is given as lambda h, okay, and probability of one service is mu h. I'm writing it out so that you can remember. It becomes very difficult. Let us do this. Probability that one arrival is lambda h. So as because we have the assumption that there will be only one event, there will be no option of two arrival. There will be always either one arrival or no arrival. So the probability that there is one arrival is lambda h, and probability that there is no arrival is 1 minus lambda h. So we have two options, either one can arrive or no one can arrive. Both together the probability will 1. So if the probability that one arrival is lambda h, then the probability of no arrival will be 1 minus lambda h. Similarly, probability that one service is equal to mu h. That means probability of no service is equal to 1 minus mu h. Sorry. Okay. So let's get back to the situation. The probability of one arrival is lambda h. Probability of no arrival is 1 minus mu h. Then the next term, Pn plus 1 at time t into probability that one service is mu h, and probability of one arrival, sorry, probability of no arrival, that will be 1 minus lambda h plus,
Hello, sir.
yes,
Sir, in the first term, why you have taken Pn minus 1t?
were you present in the last class?
Yes, sir.
I discussed it. At time t period, the probability that in the system there is n minus 1 number of person, that is represented by p suffix n minus 1 at time t. Pn plus 1 means at time t there was the probability that in the system there is n plus 1 number of person,
Okay, sir. Okay.
and Pn means there was n number of person in the system. No one came in, no one got serviced. So that means probability of no service 1 minus mu h, probability of no arrival 1 minus lambda h. Okay, is it clear? how we got this mathematical expression? No
Yes,
questions.
sir.
Okay. Okay. So now we will simplify this equation and take out the higher order terms, as because the small h is a very small interval of time, very small quantity h. So that's why whenever there is a term which is multiplication of small terms or higher order terms, we can negate them, we can neglect them, and let us see what we can find out. Here we get Pn into t plus h, and here we get Pn into t. I mean Pn at time t. Now here if you find there are 1 into 1, that is 1, there is one term of mu h, one term of lambda h, and there is a higher order term lambda into mu into h square. So that h square term will be higher order term and that will be neglected. So in this way, this 1 Pn at time t can be taken out on the left side. This Pn into t can be taken on the left side, and I am writing this up just one with a one step jump. Okay, so that we can manage the whole thing in a single page. Otherwise, it will become very difficult. So you can understand. You are intelligent enough. So we can write this in the left side and rest portion will be on the right hand side. Now from the right hand side, from each term, if you look, there is h common. Here there is h, here there is h, and here of course there is h. So the h is taken on the left. Okay. Now here the term will be p into n minus 1 at time t into lambda. Okay. You can do it yourself along with me also for better understanding. P into n plus 1 at time t into mu minus Pn at time t into lambda plus mu. Okay, this is what I get. Okay, on simplification we get this. Now we have discussed steady state and transient state in previous class. Can you remember what is steady state? Anyone please reply. What is steady state?
Sir, steady state means it is independent of the time, sir.
Very
T.
good, very good, very good. So we have to remember that steady state means the properties in the queuing system are independent of time. So that means the probability that there is n number of system, there's n number of person in the system will be independent of time. So all these probabilities here with times will be just become constant. So here, let me show you here. So Pn into t plus h becomes Pn because this becomes time independent. Whatever the time is, the probability won't change. And Pn at time t, that also will be Pn. So at P into n plus 1 at time t will become as Pn plus 1, and Pn minus 1 at time t will be denoted as Pn minus 1 because the whole properties are independent of time. Now, so if we remember this and we put it over here on this equation, okay, then you see this becomes Pn, this becomes Pn. So this whole quantity on the left becomes 0, right? Now, here these t's will be neglected, and upon rewriting the equation, so we will write at steady state condition this occurs. Okay, now we can rewrite the equation. So upon rearranging the equation, we get lambda into e into n minus 1 plus, as because these were minus, so that's why we are taking we will take the this one on the other side. So okay, so we get a equation where lambda into Pn minus 1 plus mu into Pn plus 1 is equal to lambda plus mu in bracket into Pn. Okay, so I'll write this equation as equation 1. Okay, you need to remember this. This is a very precious formula, and with help of this formula we will go on and we will work on it, and we'll derive more formulas. Okay, so look at it. Now we will advance to our next subtopic. Okay, now so the probability that there is 0% in the system, probability that there is 0% in the system. So how can we denote it? Sorry, at time t plus h, just like the first derivation we have done. We just put here n equal to 0. Let us see what we can get. So p 0 or p naught, which gives us the probability that there is 0% in the system at time t plus h. That will become p1 at time t into that probability there is 1% in the system, that is p1, into probability of one service into probability of no arrival. Okay, so there was 1%, probability of one service into probability of no arrival. Okay, so there was 1%, one got serviced in time period h. So now there is no person. Plus, what else may occur? That there was 0% in the system into probability of no service into probability of no arrival. Now what else may occur? There was no option else, because there will not be possible that there was -1 person, later one came, so that person is not possible. Okay, so this is up to this, because the number of person in the system cannot go negative, so it will up to this point. Okay, now there is a twist here in the next line. You have to be very cautious. So this, the probability of 0% in the system at time t plus h is given by, I'm putting the values, p1 at time t into that probability of one service given by 1 minus, probability of one service given by mu h. So we will write mu h into probability of no arrival, 1 minus lambda h, plus p0 into t into probability of no service is 1 minus, look carefully what I was saying, and I almost had the same mistake what I was warning you, the same mistake I have almost done. If there is 0% in the system, then the probability of no service is 1, because there is no option to service, no one is there, so absolutely there is no service, there is no options, so that means this probability of no service will be 1. So the probability of one service will be, probability of no service is 1. Okay, is it clear? The probability of no service is 1. Is it clear why we are writing probability of no service is 1?
Yes, sir. Yes, sir.
Okay, into probability of no arrival is 1 minus lambda h. Excuse me, I have a phone call, very disturbing. Hello, hello, yes, হ্যাঁ হ্যাঁ বলুন, আমি পরে কথা বলছি, ফোনটা নিয়ে একটু ক্লাসে আছি। Okay, sorry about that. Okay, is the line clear, or do you need to repeat it?
টু প্লিজ
হুম,
ওয়ান্স স্যার আরেকবার বলুন স্যার প্লিজ ওই লাইনটা
ঠিক আছে। ওকে, ফার্স্ট লাইনটা বুঝতে পেরেছো?
স্যার
Okay, so here this remains same, probability at time t plus h there is 0%. Now here p1t means at time t there was 1 person into probability of one service, so probability of one service is mu h, we have written mu h, probability of no arrival is 1 minus lambda h, just we have discussed in earlier. Now we assume that there was 0% in the system, and the probability given by P naught at time t into probability of no service into probability of no arrival. So here, if there is 0% in the system, then of course there will be no service because there is no one to service. So there is only one option, and the whole probability is assigned to that, because this is certain. If there is no person, then there is no chance of service. So the whole probability is assigned as 1 in this case, probability of no service. That's why I have written 1 here, and probability of probability of no arrival is given by 1 minus lambda h. So here, this is where you need to be cautious of. Okay, if there is no person in the system, then there is no one left to service. So that's why the probability became 1 of this particular option, because there is no other option. Okay, is it clear now?
Yes, sir.
Okay. Now, upon rewriting this in a proper way, let me do it directly. We just rearrange it, just like previous case. We have already discussed, so you can understand. You are intelligent enough. Okay, we have just rearranged we have simplified the multiplication form, and we have rearranged it just like we have done in the previous derivation. Okay, so here, applying condition of steady state, we know what happens in steady state. All the probabilities will become time independent. So here, if this becomes time independent, this also becomes P naught, this also becomes P naught, and the left hand portion becomes 0. Okay, so what we get there, this portion only, but without t's. So we can write this mu into P1 will be equal to lambda into P naught, and that will be our equation number 2. Okay, clear? So from here we can also write that P1 is equal to rho by mu into P0 or P naught. Now, in equation 1, okay, earlier we have derived equation 1. If we place n is equal to 1 in equation 1, okay, I hope you remember equation 1. I'm writing this up, lambda into, I'll just write equation 1 so that you can relate. Okay, this was the equation 1. Now we'll put n is equal to 1. So if we put n is equal to 1, what we get? P naught here plus mu into P2 is equal to lambda plus mu into P1. Okay. Now here, let us again simplify lambda P1 plus mu P1. Now, putting the value of P1 from here, okay, we'll put the value of P1 from here. Let us see what we can get. Here we get P2 is equal to, we replace this mu P1 as per equation number 2. Okay, so let us do it one by one step at a time. Lambda P1 plus mu P1 is equal to lambda from equation number 2. You can see, okay, this is what we can get. So here this and this will be cross out, so we get P2 is equal to lambda by mu into P1. Okay, so now if we put the value of P1 from here to here, what we get? Lambda into mu, lambda by mu whole square into P naught. So from these two equations, what we can get? We can remember that lambda by mu is given as rho, which was traffic intensity we have done in previous class. So we can write as P1 is equal to rho into P0, P2 is rho into P1 is equal to rho square into P0, P3 is equal to rho into P2 is equal to rho cube by rho cube into P0. Okay, so this is the way it will advance, and Pn can be written as rho into Pn minus 1 or rho to the power n into P0. So if you can get P0, then you can get that Pn if the n is a known quantity. Okay, is it clear?
Yes, sir.
Okay, this is very simple. You just need to focus. That's the point. It is very simple. But once you have understood that, once you can understand, you will not forget. It's very easy. So now we have a very small time left, so let us complete another term over here. So there is 0 number of person in the system plus there is P1 number of person in the system, or P2 number of person in the system, P3 number of person in the system. Similarly, up to infinity person can be in the system, and all their probabilities together will be 1. So we do not know how many number of person in the system. The probability that there is 0% in the system is P0. There is probability maybe 1% in the system, that is given by P1. Probability that there may be 2% in the system, that is P2. Similarly, there may be infinity number of persons in the system. All these probabilities will together upon addition will become 1. So if we rewrite P1, P2, P3 such a way it gives us P naught plus P1 becomes rho P naught plus rho square P naught, and similarly up to infinity will give you 1. So upon taking common of P naught, we get 1 plus rho square and plus up to infinity gives us also 1. So here if we apply the condition of series, as this rho is less than 1, we get 1 minus 1 by rho is 1. So from here we can write this P naught is 1 minus rho. Okay, this is a very important one to remember, because you can understand if you know P naught, you can find out Pn, and P naught can be found out if we know the rho. Okay, so now if we look, this P1 is equal to rho into P naught. So P naught is again 1 minus rho. So similarly Pn is equal to rho to the power n into P naught. So rho to the power n into 1 minus rho. So these are the small things that you can remember, and that we have to apply upon when we are solving problems. Okay, so we'll stop here today as the time is up. We cannot complete in the time, and we will continue on the next class.